So next we have derivatives of logarithmic functions. So in this section we're going to look at what is the derivative of log base, say, 2 of x, and what's the derivative of natural log of x. Okay, so here's the rule for log. So the derivative of log base a of x is 1 over whatever is that quantity. So 1 over x times natural log of a. Okay, I can show you how we get this quickly. So if you start with y equals log base a of x, and you change this to exponential form, a to the y equals x, take the derivative of both sides implicitly, I would have a to the y times natural log of a times y prime on the left equals 1 on the right. Divide by y prime, so I'd have y prime equals 1 over a to the y times natural log of a. And then a to the y, if I look back up here, a to the y equals x. So that becomes 1 over x times natural log of a. That's where it comes from, and here's the rule. 1 over x times natural log of a. Now again, if this isn't just x, you're going to have to multiply it by whatever the derivative of that is. So let's do some examples. Then I have the derivative of natural log of x. So the derivative of natural log of x or natural log of absolute value of x is just 1 over x. You do not need the natural log part in the denominator because the natural log of e is just 1. Okay? So those are your derivatives of both of them. So derivative of log and derivative of natural log. Okay? And then in both cases, you're going to multiply by the derivative of x. All right, first example, natural log of x cubed plus 1. So it's going to be 1 over x cubed plus 1. It's always 1 over that times derivative of that, which is 3x squared. And then you could write it as 3x squared over x cubed plus 1. One fraction as your answer. Okay, next one, natural log of sine would be 1 over sine times derivative of sine, which is cosine. And then I could write it as cosine over sine, which is cotangent of x. Okay, next one, natural log, the square root of natural log of x. So first I'm going to write it as natural log of x to the 1/2 power. So now I would have to do that first. So I would have 1/2 times natural log of x to the negative 1/2 times the derivative of natural log of x, which is 1 over x. Okay, so all your other rules are still going to apply. You're still going to do outside, inside. And then I'm going to write this as 1 over 2x times the square root of natural log of x, or natural log of x to the 1/2. Okay, next one is a log example. So for this one I have, I'm going to use the rule for derivative of log, which is what? 1 over x, which in this case is x squared plus e to the x, times natural log of 2, natural log of whatever the base is, times the derivative of that, which is 2x plus e to the x. So I would write it as 2x plus e to the x is my numerator over x squared plus e to the x times natural log of 2, my denominator. Okay. Next, I have natural log of x plus 1 over the square root of x minus 2. So, natural log rule I'm going to do first. And I'm going to write it as 1 over x plus 1 over the square root of x minus 2 times the derivative of this, which I'm going to have to use my quotient rule. So I would have the derivative of the numerator first, which is 1 times denominator, x minus 2, minus numerator times derivative of denominator, all over denominator squared, which would just be x minus 2, guys. Okay? Now, if you simplify this a little bit, okay, if I simplify the numerator here, and then this is a complex fraction over here, so the left side really just becomes the squared x minus 2 over x plus 1, because it's just divided by the reciprocal. Okay, that's what I'm going to get over there. And then the right side here, you could leave that as it is and factor out an x minus 2 to the negative 1/2, to the negative 1/2 power. Okay, and see what you're left with. So if I factor out an x minus 2 to the negative 1/2, then I would have x minus 2 the first term, this, minus 1/2 times x plus 1 all over x minus 2. Okay? And then you could simplify more. This is really x minus 2 to the 1/2 power. So this, and this, that would really just go away. I would have x minus 2 to the 0. So that would go away. And then I have my denominator is x plus 1 times x minus 2. My numerator would be, just simplify this, guys. So it would be x minus 2 minus 1/2 x minus 1/2. So what do you have there? You have 1/2 x, and then negative 2 minus 1/2 would be what? That's negative 2 1/2. So negative 5/2 over the denominator. And then if I didn't want the fractions in the numerator, I could just rewrite it as x, I'll come up here, final answer, x minus 5 over, if I just factor out the 1/2, the 2 would become part of my denominator. So that's just algebra to go from here to here, factor out a 1/2, okay? And then that becomes down here because I have 1/2 times. All right. The next problem here, I'm going to have to erase some of this to squish it in there. So log base 3 of that quantity. So first you're going to do your log rule. Oops, sorry, I erased the problem. First you're going to use your log rule to do the derivative of log base 3 of that 3x squared. Okay, so I would have 1 over 3x squared plus 5 times natural log of 3 times derivative of that, which is 6x. That's part of the numerator, so my final answer would be 6x over 3x squared plus 5 times natural log of 3. Not bad for that, that next one. All right. Now I have redo this problem that was just really long to simplify using your laws of logs first. Why would this help us? So if I wanted to, I could, before I do any differentiation, I could use my laws of logarithms, which say what? If I'm dividing two quantities, I could separate them by subtraction. So first I could do that, would be natural log of x plus 1 minus, and then, hopefully you remember this from last year, I could bring the 1/2 in front of natural log of x minus 2. Now I could just differentiate each term, guys. So the derivative would be, derivative of that would just be 1 over x plus 1 minus, leave the 1/2, times the derivative of natural log of that would be 1 over x minus 2. So I have 1 over x plus 1 minus 1 over 2 times x minus 2. And then if you found a common denominator, you'd get the exact same answer. Okay, so go ahead and find a common denominator, and you would get x minus 5 over 2, x plus 1 times x minus 2. A little bit easier by using your log. So if it's a log problem, and it's somewhat complicated, you can use your laws of logs or natural log to rewrite it. So remember, division, subtraction, and multiplication would be addition. Okay. Last thing I have here is the logarithmic differentiation. Okay, so it's used to find the derivative of more complicated functions by basically turning it into the last problem, like this. All right, so I have the steps here that you can refer back to. You have them on the sheet. Take natural log of both sides, differentiate implicitly, and then solve. So look at this problem. Now the difference between this and the last problem I did is there is no natural log in front of all this stuff. So the first thing you have to do is create it as a natural log function. To do that, you'd have to take the natural log of both sides. X squared plus 1 over 3x plus 2 to the 5th. Okay, now you could, let me just go back. You could find the derivative of this using your quotient rule, but this is going to be a little easier. Okay. Now that I've taken natural log of both sides, I'm going to find the derivative of both sides. So the derivative of natural log of y would be 1 over, I'm sorry, hold on a second. Before I do that, I want to now use my laws of logs on the right side to separate this. So I'd have natural log of y equals, and then using your laws, you'd have 3/4 natural log of x plus 1/2 natural log of x squared plus 1 minus 5 times natural log of 3x plus 2. So that's using your laws of logs. Okay, I bring the power in front, and multiplication's addition, and division subtraction. Now I can go ahead and find the derivative of each term. So the derivative of natural log of y would be 1 over y times y prime. So 1 over y times y prime equals, first term would just be 3/4 times 1 over x. The next term would just be 1/2 times 1 over x squared plus 1 times 2x. And the last term would be 5 times 1 over 3x plus 2 times 3. So now all I'm going to do is rewrite these so I have one fraction each time. Okay, so this would be 3 over 4x plus, the 2's are going to cancel the next term. So I would just have x over x squared plus 1 minus 15 over 3x plus 2 equals 1 over y times y prime. Now you just have to solve for y prime, so multiply both sides by y. So your answer would be y prime equals all of this times y, if I multiply by y. And then the last step is you would go back and I would put the actual function in for y. So it looks really messy. So I would have x to the 3/4, the square root of x squared plus 1 over 3x plus 2 to the 5th times all of that. And that would be my final answer. So my last step is to plug back in for y. Now when would you use this again? If the function to start with was really complicated, this is actually easier than doing the quotient rule. You could do the quotient rule and product rule within that, or this is another option. Okay? Now the next problem, you have to use logarithmic differentiation because you have an x as your base and x is in your power. There's no other way to do this. I can't bring down the root x. You only can, obviously if it's x squared, you can bring down the 2 and subtract 1 from it. But I can't do that when the variable, when the power has an x in it. Okay, so what do? You take natural log of both sides. Okay, use your laws of logs to rewrite the right side. So now the laws of logarithms, I can bring down the root x times natural log of x. Now I'm going to differentiate both sides. So this would be 1 over y times y prime equals, when I go to do this, I need to use product rule here. So I'd have 1/2 x to the negative 1/2 is the derivative of root x. Okay, times natural log of x plus root x times 1 over x. Okay, simplify this a little bit. So I'd have 1 over y prime equals this first term. If I simplify that, sorry, I would get natural log of x over 2 root x, and then plus, what's this? This is root x over x, which you could actually write as 1 over root x. Okay, and then the last step would be to multiply both sides by y. So y prime would equal y, which is x root x to start, times natural log of x over 2 root x plus 1 over root x. If I do x to the 1/2 over x, then I would get x to the negative 1/2, which is 1 over root x. Okay, so you have to use this if you have x in your power to a function. You have to use logarithmic differentiation. Okay, and then I have one more down here, number 10. Your last example is on the bottom of my page. Okay, 2 times x sine x. So again, I have x in the base and I have x in my power, so I'd have to use this. So I would take natural log of both sides, 2x sine of x, okay, and then I would use my laws of logs on the right. So I'd have natural log of 2 plus natural log of x sine x. Remember, multiplication's addition. And then I could bring the sign in front. So I'd have natural log of y equals natural log of 2 plus sine x times natural log of x. Now I could find the derivative. I'd have 1 over y prime equals derivative of that is 0. Over here I'd have to use the product rule. So derivative of sine is cosine times natural log of x plus sine times 1 over x. Simplify a little bit. So I'm going to write the last one as natural log of x plus sine x over x. Okay, and then multiply both sides by y. So y prime would equal my original function, which was 2x to the sine x times cosine x, natural log of x, plus sine x over x. There's my final answer. Okay, so again, you're going to use this. You're going to take the natural log of both sides when you have x as the base and x is in your exponent.